Hello everyone. Welcome to the March JSE webinar. I'm Lee Harold Williams, an Associate Editor for JSE. In a moment I'll introduce today's speakers. I'd like to remind everyone how the webinar will work this morning. Our speakers will have about 20 to 25 minutes for the presentation. We'll have time for questions and answers after that. If you have questions, please type them in the question box anytime during the presentation or afterwards. I'll ask the speakers those questions to start off the question and answer session. After that, if you raise your hand, I can unmute you and let you ask your question and start a discussion that way if time permits. So I'm very excited today to present Larry Lesser and Amy Wagler from the University of Texas at El Paso. They're going to be talking about their November 2014 paper that was in JSE. There you go, Larry.
Thank you. Good morning and good afternoon to everyone. So here, this is the trying to get the slide to advance. I'm not sure why it's not. This is one of the reasons. Yeah. Okay. Can we see that? Is that good? Okay, like that. Okay, all right. Okay, so this is the outline of the paper. Obviously, with the webinar format, we're only going to hit some highlights to briefly motivate and illustrate the model, go through a few pedagogical considerations. Then Amy will talk about how we assess the model, and then we'll have time for discussion. So this is a slide that we just added recently. The median is a very simple concept in many people's minds, but I don't think all instructors know that the median, first of all, can actually be less than the mean, even for a right-skewed distribution. And that comes from some discussions in JSC letter and a follow-up by von Hippel. Also, that the median, just like the mean, has a physical model for it, representation for it, and that the median being unique for an even sample size is not an absolute thing, it's just a convention, and it's not even a universally accepted convention. And finally, that it's always within one standard deviation of the mean. Those last three bullet points are all listed and referenced in our paper if any of those are new for you to investigate. Also, just because students can procedurally compute the mean does not imply that they understand it conceptually. Growth and Bergner reported that on a NAEP item, only 4% of high school students in grade 12 correctly chose with the right explanation the median as the measure of center to summarize a data set that really called for the median, and that only 3 of 45 pre-service elementary school teachers gave descriptions of the median that addressed the ordering property as well as the median not having to be a value in the data set. So obviously more needs to be done with the median. Now from the GAZE guidelines that I'm sure all viewers are familiar with, that we have the balance model for the mean, and we also have a picture of a balance model for the mean in our paper there in the bottom right corner. But what's not as well known is that there's also a balance model for the median. This is a teaching tip by Mark Lynch at Millsaps College in Jackson, Mississippi. And this is the whole article. It's just this one page or 2/3 of a page long teaching tip that appeared in College Mathematics Journal. And by the way, the moral of this story is how important it is to share cool ideas you have, even if you think it only is going to take up a half page as a teaching tip, because without seeing this, I would not have known about this, much less been inspired to, turn it into a full-fledged paper, which Mark was very delighted and honored that we did that. So anyway, as you can see, it involves a pulley and a loop model. And so when I saw that, I just thought, this deserves to be more well known, because no one I asked had heard of this. So from figure 1 of our JSE paper, this is what the model looks like. This is really a screenshot from a video we made. It involves a 4-inch in diameter clothesline pulley wheel, a 6.5 foot piece of twine tied into a loop marked at 2-inch intervals. You can actually see the markings of the 2-inch intervals, and several 2-inch office binder clips. And I have the word colored there because even though in this screenshot they're all black, Rebecca Pierce gave me the excellent feedback that these binder clips actually do come in different colors, at least a half dozen different colors. And so that can be a further improvement or refinement of the model when you use it in your classroom. So as you can see, this is very low tech. You can buy all these materials for under $10, and you've got a working physical model of the median. Now, there are some similarities between the mean and median balance models. Both can be built very inexpensively. A stick on a fulcrum is, you can do that inexpensively for the mean. They both support prediction questions like, what if we have an outlier now, that kind of thing. And they both show that a particular measure of center need not be a value in the data set, but always has to be somewhere between the minimum and the maximum. So those are some similarities, but there are also some differences. With the mean, you have to find the balance point by trial and error. You have to just sort of try different places to put the fulcrum to see where it balances. Whereas the median model, as we will see, it finds the balance points automatically. It just goes to it. So that's a cool feature of it. Another feature is that with the median model, that the weight of the loop does not matter. With the mean, however, the weight of the board or the platform, the stick, whatever it is, that actually does matter. It turns out the balance point will equal the true mean only if it's at the midpoint of the stick. Well, that's kind of limited general use. I mean, you can contrive an example and make it work just for that example, just to illustrate things, but beyond that, it remains just a theoretical thing to draw pictures of and wave our hands conceptually, but not as a practical tool to find the mean rather. And so again, we made this 1-minute demo video. It was a fun challenge to sort of take a 28-page paper with over 50 references and boil the whole point of the article down to less than 60 seconds. And I think we did. There's 2 URLs where you can find it. There's my personal YouTube channel as well as a JSC hosting. So even if one of them is down, hopefully the other will always work. And so that link was also on the JSC webinar page, so we invite you to see that at some point if you haven't already. The nice feature about it is that the questions are posed on the video itself, so that as a teacher, if you don't want to take the time to go out to the hardware store and buy the materials and build it and take up class time doing it yourself, you can just show the 1-minute video, because everyone's got 60 seconds in their class lecture time or for professional development workshop time. And so you can pause the video at 2 key points and let the students make predictions before resuming it. And so we're going to sort of simulate that here. The first question the video poses is, when I lift my index finger so the string is free to move, what will be at the bottom of the loop for this set of 3 weights which are clearly unequally spaced? And as you can see, what happens is what goes right to the bottom is the middle binder clip, the middle position of the 3 ordered values, which is a way of showing that the balance point really is the median. And then the second question that the video poses is, what happens when I lift my finger now when there's an even number of values, or binder clips in this case, and again, they're not equally spaced. And when I lift my finger up, as you can see the finger goes up, nothing happens. It stays the same because it's already in equilibrium, even though it wasn't halfway between those 2 middle values, which is a way of illustrating the arbitrariness of the convention to always take halfway between the 2 middle values, because this will balance at any point between the 2 middle values. And on the video, I tug on the string a few more times to show that it remains stable any point in between those 2 binder clips. So when you watch the video, just keep your focus on the model. Lee made the comment, which is probably true, that I looked a little too serious, and she's right. When Mark Lynch saw the video, he loved it, but his point was that if I had Vanna White holding it, that I would have gotten more hits on the video. So anyway, so while the binder clips was just sort of like, data that, you don't have to even think about the numbers, the article does have data sets with actual numbers with a real-world context. And so it has a little more detail. As you can see, when you go through the data sets, the first data set is an odd number of equally spaced values, and then we change that 20 to an outlier of 10, and then we add 2 to each value. And again, every time you do this, you hold the string fixed and ask the students, what's going to happen when I lift up my finger so the string's free to move? What's going to happen? And they make their predictions. And then we have the data set including some repetition, and the first time we have repetition in row 4 there, the 12, 24, 24, 30, 30, if students take into account repetition or not, you're actually going to get the same answer either way, because 24 is the middle value of the 3 distinct values and the middle value of the 5 overall values. However, in the next data set, there's 7 values with repetition where the middle value of the distinct values is different from the middle value of all the values, and so you have that little twist to it. And then we go to the example of even number values where the middle two are the same, namely 24, so no one's going to predict anything except 24 for the median. But then on the last one, the middle two values are not equal. We have 24 and 30, and the median will not be unique in that case for the same reasons we just discussed there. And so now I turn over the headset to my UTEP colleague, Amy Wagler.
Hi, everyone. Hopefully you can hear me. I'm going to go over the assessment of this activity. I'll be going over the population, the methodology we utilize, the instrument for assessing how much they understood from the activity, and then also the results of that and a discussion of those results. So the setting of the study was a southwestern U.S. research institution with a predominantly Latino-Latina population. The class was a pre-service middle school teacher's course. It was actually a pilot version of this course, and we actually thought this was a very good population of students to test this model on because, number one, they'll be teaching this concept as middle school teachers, and there was some documentation that, well, elementary school teachers, but middle school and high school age students aren't understanding some of the details of conceptual details of the median, and so this seems like a very appropriate audience for this activity. Those who completed both the pre and post tests was 10 students out of the 13 students in attendance at the class. So before we did anything with the activity, a pretest was given. We had 100% informed consent for that pretest. The students participated in the median activity for about 45 minutes in class. Now let me say, by no means do I think that this is a required amount of time. This was really for research purposes. I've used the video several times now in my own introductory level classes and probably devoted less than 5 minutes each time and seen good results anecdotally. The median activity included a lot of in-class voting questions, so we used the voting cards, if you've seen those before, that you can respond with, and they get a set of choices, typically A up to C or D, and then they respond with their prediction about what they think is most likely the answer. Then directly following the activity, they completed their post-test. The data was analyzed by a statistics graduate student and then provided for the paper. Here's an example of a representation of what went on in class during that 45-minute class session. So this is for that first data set where it was equally spaced. We've divided up this in-class assessment protocol into 3 columns where we have the instructor prompts, ideas for what you could say as the instructor, questions to help engage the students in that middle column. This also includes the voting cards questions. So whether you're using clickers or voting cards, or just even they could indicate option 1 or 2, say, on this, instead of A and B using their fingers or something in class. This is a way for them you to get instantaneous feedback there in class. And then some targeted observations. So these were either things students said or ideas we had that were important to point out during the course of the activity. For the pre and post test, there were 10 questions overall. 5 were strictly multiple choice. 2 were multiple choice, but followed by an explain, because we really wanted to hear the students' reasoning for their choice. And then 3 were open-ended. A majority of the questions were actually either taken directly from or adapted from the artist database. One was actually created by us. There was one, and that's, we're going to talk about that item in just a bit, but there was one concept that we really wanted to assess that wasn't addressed with the items we had selected. So here's one adapted from the artist database. I'll give you some time to read this. Okay, so when I do my questions in class, I always give the class time to read it. I ask them, does anybody need more time to think about their answer? And then we usually do an answer in voting cards, but this was actually a written response one where they needed to also explain their reasoning. Here's another example of an item. This is one we wrote. I'll give you some time to read it. So the big idea here is that those top weights, the very heaviest wrestlers, we could not exactly weigh them. And so we only knew that they were 250 pounds or more. And so these are outline points, and we wanted to see how students respond if they don't know the exact value of those 9 points. To assess all of the pre- and post-test responses, we did first a global test for the proportion correct. Then we did follow-up analysis for each item. The p-value for the global test was somewhat marginally significant, and so we followed up with some multiplicity-corrected proportion tests. And if you look at the results on this slide, we might focus in on, let's see if I can get my, there you go. Item 4 here is one I want to focus in on first. This is where we were asking the students to compare the mean and median for skewed data. They needed to recognize the effect of outliers on the relative position of the mean and the median. Before the activity, only 20%, or 2 out of 10, could answer the question correctly. After the activity, 9 out of 10 did. So this was our most positive result that we saw. We also saw a majority of students for a related in-class polling question. This polling question is number 6 as contained in the appendix of the paper. That most of them got that right. So this seemed to be something that physical model for the median really helped them understand. I can say when I've taught a similar population of students in the past, they often would get the reasoning behind when the median and mean would be greater than or less than confused. And with this physical model, it seemed to really clear up that confusion. Other questions, we didn't see much of a change, or with the multiplicity adjustment, it wasn't statistically significant, but we did see some more marginal gains with some of the items. We also had those open-ended responses. Recall we had 3 strictly open-ended response questions, and then the 2 that just were a simple explain for multiple choice question. And we had 3 statistics graduate students from our department rate these. These were students very accustomed to grading student work in our department. From a scale of 1 of virtually no relevance, meaning their answer really didn't have anything to do with the question being asked, up to completely relevant, addresses all aspects of the reasoning process. And here's brief descriptions to those open-ended items, as well as a measure of the inter-rater reliability using the ICC, the intra-class correlation coefficient. Unfortunately, some of our ICCs were low enough that I'm not really going to believe the mean ratings too readily. But thankfully for item 4, which also was asking for the comparison of the mean and median for skewed data, and the student responses not only improved on average, but the raters' reliability was very good on these. And so again, we see some evidence that they really did get a clear conceptual understanding about that relationship between the mean and the median when we have skewness in data. So an overall of the results, kind of what did we get from this? Again, what I've already pointed out, the mean and median are affected differently by outliers. That really tended to be the biggest insight gained among the students. But they really also tended to get the idea that the median need not always be unique. However, we noticed with certain items, if you look in the paper or on some previous slides, some of the in-class polling questions they did quite well on, but it didn't transfer well to once the physical model was not in front of them anymore, they couldn't transfer the concept well to an applied question. And so perhaps this brought up the idea of perhaps we need to be reminding them about this physical model as we do more practice questions over the median in class. Give them cues to help them reflect and recall what they learned from this physical model. We did see that students really were able to recall that they needed to order the data for finding a median, and this really provides that concrete basis for understanding that, because those points on the string are naturally ordered, so they can, we even thought about taking the string off the pulley and laying it out and saying, see, we can see the natural ordering, and it's ordered whether it's in a loop form or if it's in a straight line. And finally, it reinforces the idea that the mean and the median need not always be an observed value of the data set. And we did have some limitations, delimitations. We were working with pre-service middle school teachers. In a way, these provide that upper bound benchmark. If they're struggling with the median concepts, which we did observe, we observed lots of issues, especially in the pretest, then we expect middle school students will even more. The sample size is small. That was partially due to the fact that this was a pilot course that semester, and so it wasn't a large class size. And so as a result, the research results here are very preliminary and not at all definitive. Well, thank you for listening. I guess it's time for questions and answers.
Okay, we did have a few questions or comments during the presentation, so I'll go through those first, and then if anyone has questions, you can raise your hand and I can unmute you after that. So the first one was a comment about the definition of skewness and with regards to whether the median is lower or higher than the mean for right or left skewed data. And so with your data, did you look at both? So this is my posing question off the comment. So did you work with skewness in both directions, or were you only focused in one direction? And how did you define skewness with the students?
So the data set that we used in the article has an outlier, and it's a low outlier. You know, there were that sequence of 7 data sets didn't allow us time to do the high outlier and the low outlier, but certainly you could modify this. I just thought that people are used to outliers always being a high value, you know, and so we made the outlier low for our purposes.
Okay. Sorry. Did you have more to say?
Oh, not on that, but I just thought of something that towards the end when Amy was talking about the idea of draping the loop around it, because the model that we had pictured has the loop attached to the pulley, basically. But another option I just wanted to mention is that you can use like a hacksaw to cut one of the plastic legs of the pulley, and that allows students to easily remove the string from the pulley and redrape the string over that. So just a extra little twist on that. So go ahead and go to another question if you have one.
Okay. So how much familiarity with physics do the students need to find these demonstrations useful?
I don't really think, certainly no more than you would say that they need physics to understand the one for the mean, the balanced model for that, and we all present that without thinking twice about their physics background. So I think students pretty readily catch the idea of equal numbers of things on both sides of the loop. That's, if anything, an easier concept, I think, for most students.
They just need to understand that point of equilibrium, right? And they can visually see that. And I agree. I think it's a little easier conceptually even than using the fulcrum model.
Yeah, because the distances really don't matter. It's just whether you're on the left or right side of the loop.
Okay. I'm going back to the first question. How did you actually define skewness when you're working with the students?
Well, the course, it doesn't go into like the third moment or whatever. It doesn't go into anything mathematically advanced. It's just a way of talking. It's just more of a descriptive word used to describe a data set. Yeah.
Is that what they were getting at?
Okay. And then someone provided another example that you could use. The median involves where to park a car when trying to minimize the steps when you're going into a series of different stores.
Yeah, I think email had emailed that to me, and I like that example. The one we use in the article, I think, is a little more robust in the sense that it involves where to stand in front of a bank of elevators, because the elevators have to be on a one-dimensional line, and so the distance, to minimize the distance you might have to walk before the right elevator arrives, involves the median. But and again, this won't totally make sense unless you've read that part of the article, but it's in there. Whereas with the parking lot, it's really a two-dimensional situation because you're not going to have all the parking spots all in one line.
Okay, great. Does anyone else have any questions? I've asked all the ones that had been typed in the question box. Okay, well, we're about out of time anyway, so I want to take a moment to again thank Larry and Amy for being our presenters and presenting both screenshots from the video, so if you haven't seen the video you could understand what they were talking about, and the research they did with the pre and post assessment items.
And thank you for hosting.
Thank you. On your way out of the webinar, please remember that there is a feedback box, and please leave us any comments about how we may improve the webinar series, or if you have any ideas for articles to nominate for the webinar series. Thank you.
Thank you.
Thank you.